Hashicorp uses Go programming language as the main language for its tools. So, if you are interested to develop custom provider for Terraform, you must be familiar with Go development. Hello, I am Marin Salinas, software engineer here in Digital on Us, and welcome to the Go programming language video. In this video, we will take the initial steps into the world of the Go programming language and learn using of to write, build, and run Go programs. But before we jump into the code, let's learn some of the reasons behind Go and what it's good for.
What is Go? Go is an open source programming language created by Google in 2007. Go makes it easy to build simple and efficient programs. Here are some main characteristics. First, Go is a compiled language, meaning we must run our source code through a compiler, which reads that source code and generates a single executable file which we can use to run our program. Throughout this video, we will talk about data types like integers, strings, and booleans. And we will learn that the Go compiler validates operation involving these types before we run our program. This leaves less room for unexpected surprises when you run it, and places Go in the category of statically typed languages. Go programs are fast and can scale really well thanks to the concurrency model that is built into the language, and it's quite easy to use. Go programs are also easy to deploy because the compiler generates a single executable file. Sometimes, deploying a Go program to production can be as simple as copying the executable over to the server. And last but not least, it is a language that is just fun to write. The question here is, what types of programming should we use Go for? And the answer is systems programming. Systems programming is a type of programming aimed at servicing other systems. These lower-level programs are often than not will not expose a graphical user interface, but instead they'll run straight from the terminal or the command line. For those with experience in building web or mobile applications, I know that sounds a little different than usual, but here is a quick comparison. Programs that provide services directly to humans are called application programs. These allow a regular end users, most times without any technical background, to perform common tasks. Examples of these types of programs include e-commerce, to-do list apps, text editors, and music players. Programs that provide services to other programs are called system programs. Examples include APIs, game engines, network applications, and command line applications like Terraform or Vault. In this video, we will look at the most common feature used when writing programs in Go. These include how to build and run programs, importing and creating packages, basic constructs like functions, variables, loops, conditionals, how to work with different data types, and finally, how to write a concurrent code using Go routines. Let's write our first program. We'll write our code to a single source code file. Then, we will compile that file using the Go compiler, which generates a single binary or executable file. Running the file, the program will print hello world to the console. Now, let's see how we can write this. Here on the left is a typical Go workspace. The source folder is the root for all our Go projects, and we will create a new folder for each project like we are doing here with Go Basics. Under the new folder, we can find a Go source code file with a .go file extension. Since the Hello World program we have a single file, we'll call it main.go. And this is the naming convention, not a rule. Inside our main.go file, the very first thing we write is in the package definition, package main. Then we define the main function using the func keyword. This function is the entry point for our Go program. All runnable Go programs must have a main package and one main function. In order to write to the console, we'll learn to import a package from the Go standard library called FMT, which means format. Package imports go after the package definition. Then, from inside the main function, we call the println function from the FMT package, giving in the string hello world. Notice, semicolons are not necessary, and this is all the code that we need for now. Now, let's see how we can run this. As I mentioned, the compiler reads the source code and produces an executable file. Well, this process of reading the source code and resolve package dependency and generating a single executable file, it's called a build process. In order to build our Go project, we use the build command shipped with Go. We run go build from the project root folder Go basics. The compiler will produce an executable file named after the project Go basics but without extension. Using this file, we can run the program and see the message print to the screen, Hello World. You might be wondering if there is a way to run Go programs without this intermediate compilation step, and the answer is yes. We can use go run, another command that's shipped with Go, and give it the name, file name, that main.go. This is the simple command out the program we will build and run, and we can see the same message printed on the console. This command is used for development, and this is what we'll use for the rest of this video. Another command that's shipped with Go and can greatly increase productivity in development is called Go FMG. We can use this command to format Go source code. There are many benefits to following Go FMG rules, instead coming up with your own individual standards. First and foremost, we get to avoid most debates around code styles. Also, by not having to worry about these minor concerns, it's become easier to write, read, and maintain programs. So now we will learn about writing conditional, reading user supply arguments from the command line, and package imports. Let's write a new program that reads a user supply argument from the command line and prints it back to the console. We will use the same main.go source file for this, with the main package definition up at the top and the package FMT imports right below. Then, from inside the main function, the first thing we will do is add an if statement. Unlike other languages, if statements in Go require no parentheses, but if the if and else blocks must be enclosed in curly braces. Next, we'll use the len function built in Go, which takes one argument and returns its value, its length. We will talk about this argument in just a second, but for now, we will check if the return of the from len is greater than 1. If len is less than or equal to 1, then the program flows into the else block. Now, the next step is to pass an argument to len, which will be os.args. os.args is an array containing all arguments passed to the running program, including the name of the program itself, along with any user supplied argument from the command line. Next, the OS package must be added to the import list in order for us to access to its args property. Now, from inside the if block, we'll call the println function and give it the element on the index 1 of os.arg array, which is the argument supplied by the user from the command line. From the else block, which will be executed when no argument is passed from the command line, we'll print the default message hello world. Now, our program is complete. Let's run it and give it the argument hello from args.
The index 0 will be the name of the program, and the index 1 will be the argument. Since we have two elements in OSArg, the return from len is 2, and the if statement evaluates to true. The if block is run, and we see hello from args. Now we run the program with no arguments, Only the index 0 on OS args is assigned a value, and the call to the len function returns 1. The if statement evaluates to false, so the else block is run, and the default message is printed to the console. Hello world. Now, what will happen if we've forgotten to import the OS package? If we try to run your code like this, then the Go compiler will raise an error during the build process. But let's take a look at another tool that shipped with Go and can help us with that. Go imports automatically detects missing packages and updates import statement in the source code. So in our source code file with the missing OS package, we can run Go imports and give it the same W flag, which means we want to write the results back to the original file and give it the name of the file that we want to fix, main Go. Go imports will detect all reference to package not imported on this file and will automatically impose those packages for us. In this example, the OS package. Go imports also formats code according to Go FMT. Many IDEs have integration for these tools and it makes it faster to develop programs. Now, we'll learn how to create variables at work with data types. Let's go back to where we finished in the last section. Notice here that we are referencing the OSR array twice from two different places. This is an unnecessary repetition and indirect practice. There are two different ways to declare variables in Go, using type inference or manual type declaration. Type inference is when the data type for some value on the right is inferred during the assignment operation to a newly created variable on the left. This is where we use the special colon equal operator and it's the most common and preferred way to declare variables in Go. As an example, we can assign the string hello world to the message variable without having to explicitly tell its data type. Go compiler figured that out for us. The other way to declare variables is a manual type declaration, where the variable data type is declared prior to the assignment. When declaring variable this way, we use the var keyword followed by the variable name, and finally its data type. Then, we can assign values to it using the regular equal operator. As an example, we declare the message variable of type string and then assign in the value hello world on the line below. The ability to specify which data types are expected to be assigned to variables, combined with the fact that Go programs go through a build process, give us a static typing, which is when the compiler checks for the type's errors before the program is run. Here is a list of some of the building types which can be found in most Go programs. Int for integers, uses for numbers like 1, a string for strings like hola, bool for booleans either true or false, float for numbers with decimals, and the collection type we just saw in this example a collection of type of string represented by the square brackets followed by the string type. Also, we can use key value data structure with the map keyword. So let's take a look at this example. Here is an example of a name function that greets with different message depends on which hour of the day we run the program. Functions are the way that we can reuse the code, and it is a good practice. The way to write name function in Go is using the func keyword, then the name of the function followed by any argument they expect, and end with the data type they return, if any. Notice, arguments and return values can be optional with any data type and can be multiple. Multiple return values are commonly used to handle error in functions. The for loop is the only looping construct available, and the only you will ever need when you're writing programs in Go. As we'll see, it is very flexible and allows us to build loops in many different ways. In the code of the left, we can see three types of for declaration. The first is the complete form of the for loop with three components. The init statement executed before the first iteration, the condition expression executed before every iteration, and the post statement executed at the end of every iteration. The for loop components are actually optional. We can create loops that use variables declared previously in our code and have a single condition expression, like the second for loop. Lastly, here's something we will find in a lot of networking programs: an infinite loop. Infinite loops are useful for setting up network listening that waits for connection for clients. The infinite for loop holds the process and runs indefinitely, either until something internal breaks out of the loop or until we manually kill this process. Take a look at the right code examples. The first code is the way how to declare arrays with a manual declaration. We must set a specific size. In this example, we can see an array with only 3 elements. If you set the fourth element, the build process will raise an error. If you need to create a dynamic array, we can use a slice, which is a data type that lets us to leave out the max element, and also we use the built-in function append, which takes two arguments, a slice and a variable number of elements. Also, we need to assign the original slice in order to get a new slice. Lastly, the last code shows how to create a slice literal, that is an array with initial values. Reading element by index doesn't scale well once our slice grows, or when the exact numbers of element is unknown until the program is rolled. For that, we can use the built-in function range that returns the index and value for each element on each iteration of the loop. The example on the left uses range to get the index and then is used to access to a certain element on the slice by index. The example on the right uses range to get an index and value and then print both to the console. We will need collection of fields to get our programs with more structure. Go provides us a struct type. A struct is a built-in type that allows us to group properties or fields under a single name. This is the way we can encapsulate our code. A struct begins with the type keyword that indicates a new variable is about to be declared. Then, the name of the struct and end with the struct primitive type. The most common way to allocate memory and assign values to a struct is calling by its name, followed by the initial data wrap in curly braces, as we can see in the left code. A struct also contains behavior in form of methods. The way we define methods on a struct is by writing a regular function and specifying a struct as an explicit receiver. In the code of the right, we can see how we can specify an explicit receiver of this function. Also, we can access to the struct properties. When we call a function that takes an argument, that argument is copied to the function. Pointer allows us to reference a location in memory where a value is stored rather than the value itself. The following examples show us the two ways to pass a variable to a function: pass by value and pass by reference. The code on the left is an example that how to pass by value. It means that the function only can get the copy of the variable passed. So if we change some field of the struct, it will not change after the function. In the other hand, if you add a start sign before a type of the argument passed, as we can see in the example on the right, indicates that the pointer of the original value is passed. So if we change some field, it will change after the function. Notice, in order to assign a struct reference to a new variable, we use the ampersand operator to return a pointer. Let's talk about interfaces. Basically, interfaces provide us a way to specify behavior. If something can do this, then it can be used here. In order to create an interface, we need to specify the keyword type, following the name of the interface, and end with the interface type. In the following example, we have an interface called jumper with one method. This method is expected to be present in all types that implement this interface. For example, in the two structs, both implement the interface specifying the jump method. Now, we can use a slice of jumper as a return value of the getList function, and this list may contain these both structs. As we add more code to the main file, keeping logging for our program inside a single file gets complicated. Coding inside the main function is what really matters. One way to refactor files growing too long is to create a project packages. A new package is a folder within the project that holds logic for a specific part of the program. As we can see, our Go Basis project, it has within two packages, Grid and Model. For now, let's take a look at Model package that contains its main file called model.go. Here we have the same code for the interface example, but we needed to do a little changes. For example, if you want to get access to variables, struct, or function out of the package, they must be capitalized, as we can see in jump method and getList function. Notice, in order to follow the Go best practices, the package name must be short and clear, in lowercase, with no underscores or mixed gaps, and, if it's possible, a simple noun. The most talked features in Go is Go routines. A Go routine is a lightweight thread of execution. It's built in Go with the Go keyword. The common uses of Go routines are in networking. For example, if we want to upload many images to S3 bucket, we can use Go routines in order to run each upload call independently. The following program demonstrates how to create Go routines and how the Go routine scheduler behaves with the three logical processors. Go routines allows concurrency and parallelism, but managing them is some difficult and it's an advanced topic. But if you want to master with it, you should have to take a specific courses or read specific resources, and that's what I want to talk to you about. We are about to end this video, but before, I want to talk about how you can further learning about this wonderful programming language. Go has an official interactive introductory course to Go called A Tour of Go that covers basic syntax, data structures, methods, interfaces, and concurrency. It's available in many languages, including Spanish and French. It is a great way to begin coding in Go. Go also provides in its official wiki many community-driven resources where you can learn. So that's all on my part. I hope this video has awakened your desire to continue learning about this wonderful language. Thank you.